for practice 1, what we're trying to do is figure out at what time or what t values are we in each one of the 4 different quadrants. So there's a couple different ways we could do this. One is to just first figure out where we are when we start. So like if I plug in t equals -3, is that going to be at this point? Is it going to be at that point? Is it somewhere else? Not really positive, but let's just check. So if I plug in t equals -3, I'm going to get x equals -1 and y equals -3.5. So I know that right here, this point, okay, which has an x value of -1 and a y value of -3.5, that happens when t equals -3. Okay, so we have to remember that for every single point, there's also this kind of invisible t value that's kind of hanging out with it and is associated with it. Because both x and y are defined by that common t value. If I plug in +3, I'm going to get x equals -1 and y equals 2.5. So that's this point way up here. So that's -1, 2.5, which is happening when t equals +3. Now, that doesn't exactly help us with what we're trying to do here, which is we're trying to figure out what t values put us in each quadrant. But we now have kind of a way of starting. So I need to figure out what that t value is right there, because then I know from -3 to that t value is when I'm in quadrant 3. And then I need to figure out what this t value is right here, because then I'll be able to go from this one to this one, and I know I'm in quadrant 4. And I need to figure out this t value right here, because that will tell me when I'm here and here. So my goal here is to figure out what is the t value at the 3 points that I've labeled in red. And it's easier to start with this one right here. So what do I know about the x and y values of this point? Well, I know that y has to equal 0 because I'm on the x-axis. So let's figure that out. If y were to equal t minus 0.5, then if it equaled 0, what would t have to equal? Okay, so I just set y equal to 0 because I know at that point right there that the y value has to be 0 because it's on the x-axis, and I can see that t is going to have to be 0.5. Okay, so I know that this t value right here has to be 0.5, and I don't need to bother finding the x value because we don't care about the x value. Now, for these two, what do I know about their x and y points? Well, I know that their x values equal 0. So I'll do the same thing. If x equals 2 minus the absolute value of t, I'll let x equal 0, and I'll solve for t. So this is going to give me that the absolute value of t equals 2, which means that t can either be positive or -2. Now, I'm not 100% positive if this one is +2 or if it's -2 or if this one's -2 or +2. So I should check by taking this and plugging it into y and seeing what happens. So if I plug the positive 2 in, I will get 2 minus 0.5, and if I plug the -1 in, I will get -2 minus 0.5. So that tells me right here that this one is a -2.5, which came from the t equaling -2. This one was the positive 1.5, which is coming from t equaling 2. So I can now say that I'm in this quadrant from t equals -3 until -2. I'm in this quadrant from -2 until 0.5. I'm in this upper quadrant from 0.5 to 2, and I'm here from 2 to 3. All right, for 2a, we're just given a set of parametric equations, and we're being asked to find a specific point value at a given t value. So I have t equals 1. I'm just going to plug that in. So x of 1 is going to equal 3 minus 5 times 1, which is -2, last time I checked. Y of 1 is going to be 4 plus 2 times 1, which is going to be 6. So when t equals -1, this particular set of parametric equations is at the point -2, 6. Same exact thing for 2b. This time it's x equals 2, so I'm going to do x of 2. That's going to be 2 squared plus 1, which I'm pretty sure is 5. And y of 2 is going to be 5 plus 2 to the third, so that's 8 plus 5 is 13. So for these parametric equations, when t equals 2, we are at the point 5, comma 13. Oh, hey, I didn't see you there. It's just writing on my new whiteboard here, going over practice number 3. You want to join me? Yeah? Okay, cool. So what I'm basically going to do is just plug in -2 into both of these two equations here and get a point for that. So let's see, I'm pretty sure I get 0, comma 4. Okay, so I'm just going to figure out where that is. I'm going to put a big old point right there. Next, I will do -1, so I plug that in, and I'm going to get 1, comma 1. I'll plug in 0, I'll get 2, comma 0. I'll plug in +1, going to get 3, comma 1. And I plug in 2, and I'm going to get 4, 4, which is right here. And that's going to be my graph with some extra things, right? I want to add some little arrows in here, maybe label where we start and where we end. But that is 3A. Okie dokie, 3B. I have this lovely set of equations here, and same thing, I'm just going to plug in points, so -2 and 3, -2 through 3 for the t values into x and y, to graph these. So first one is at -4, 3. Just put a big old point there. Next one's going to be -3, -1. And then I'm sensing a pattern here, there. My guess is it's going to be here, and I'm assuming right there. I didn't go far enough yet. 1, and then 7 way up there, okay? So I end up having that point, the points right there. I'll add my little arrows, maybe label the start, and the end. Ta-da! Alright, for 3C, I have the equations here, and we have our first open-ended interval, which means that we're going to have an endpoint where we start, and then it's going to just increase from there. So we'll have an arrow on the other side. So let's just pick some t-values. I'm going to start off with 0, so I plug that in and I get 1, comma 0. So 1, comma 0. And I want to be careful about what t-values I plug in, because I'm going to have to take the square root of them. So I'm going to do the square root of 1. That will work nicely. So that will give me 2, comma 1. And then I'm probably going to do t equals 2 wouldn't work, 3 wouldn't be nice, 4 would work out nicely. So I'm going to do t equals 4, which is going to give me 5, comma 2. So 5, comma 2 is way out there. Next t-value I think I'll do would be 9. So I'm going to get 3 for the y value and 10 for the x value. And I can now connect these. I'll put an arrow at the end because it's open-ended, and I will maybe label start, and you can still put those in if you need to. We don't really necessarily have to because of that open-ended on that one side. All right, for 3D, I think you're going to recognize the shape once we start plugging in some values here, but we have x is for cosine t, y is for sine t, and we have the interval for t values are going from 0 to 2 pi. So I'm going to start off with 0, and I plug that in. Cosine of 0 is 1, and sine of 0 is 0, so I'm going to have 4, comma 0 as my first point. I think what we'll do is plug in quadrantal angles for the t values, because those give us nice clean values for sine and cosine. If we were doing just cosine values here, I might pick 60s, because cosine of 60 is 1/2. If I was doing just sines, I might do 30, because sine of 30 is 1/2, but because I'm mixed, I'm going to just pick the quadrantal angle, so 0, 90, 180, 270, 360. So if I do pi over 2 next, I'll have cosine of pi over 2 is 0, and sine of pi over 2 is 1, so I'm going to have the point 0, comma 4, which is right here. And let's plug in pi next. So cosine of pi is -1, so this will be -4. Sine of pi is 0, so this will be 0, so I'm going to be way over here at -4. And it's kind of neat, like our t-value was 0, and that's where 0 degrees falls in line. Our t-value was 90, we were up here, which is where 90 is, and when it's pi, it's right here. So my guess is when I do 3 pi over 2 or 270, that's going to be down here. And it will, because cosine of 3 pi over 2 is 0 and sine of 3 pi over 2 is -1. So that would be a -4 value. And if I went all the way back to 2 pi, I'm going to end here. So this creates a circle, and it's really important that I label the start value and its direction, which way it's rotating around the circle, and also that I have ended here as well. And there you go. We're just really pulling out all the stops here. We got a whole nother screen going here. We got new whiteboards. Oh my goodness. So it's going crazy right here. So let's figure out 4. 4 is like the last example in the video. So we're going to model, we're going to model a particle that's moving on a horizontal line. So it's moving back and forth. And what we want to do is be able to see that. So in order for us to see that, we're going to basically allow the y value to end up being t, so that y is representing time, so we can see the visualization. So I'm in parametric mode in my calculator, so I have x and y's. I'm just typing in the equation while talking to hopefully not waste too much of your time. Again, I'm going to allow y to equal t, because otherwise it's just going to go in a straight line. We're not going to be able to visually see where turns are, which is what we want. So if I go to window, I can change my t-step here to be -2, and I'm going to not that. I'm going to, 4. And t-step, that's fine for that. I have no idea. I mean, I can cheat and see what it's going to be because I've already, have the answers here. So we can just make it -10 to 10. And for the y values, we'll do the same thing, -10 to 10, just to, get it normal. So let's graph it. There we go. It looks like I'm not going to be able to see in the x direction. So I am going to increase that because it looks like it's going off screen. I'm just going to go big. Go to 20. I went the wrong direction because I'm not paying attention. My bad. Let's go -20. I'll just change that back to 10. Hit enter and graph. There we go. I'm going to hit trace. That's where I'm starting. And what I want to know is, where am I changing direction? So I want to know what's happening right here at that little turn right there. So I'm going to move forward in time. Okay, so you can see the t value is increasing. Here's t equals 0. I'm going to keep going. And at this point, what I'm going to do is now start paying attention to the x value. I want to see when is the x value at the largest, because that's going to be when it's at this furthest most point. So here it's at 2. It's still getting bigger and bigger. Here it's at 2.25, and it drops to 2.24. So I can see at t equals 1.5, it is at its rightmost point. So it's traveling in the right-hand direction from -2 to 1.5, and then from 1.5 all the way until the end, which is at 4, it is traveling left, okay, because it's moving in the left direction. If we had not allowed this y value to be t and it maybe just picked an arbitrary number of 5, it would just look like this, and we wouldn't see that curve that showed us when we could figure out where it was changing direction. So that's why we just allow y to equal t. All right, for 4b, I have the equation typed in up there. I'm going to, again, allow y to equal t. That's just so we can see the visualization of how it's turning. Otherwise, it's just going to graph in a straight line, and we won't see very much. For the window, I'm going to change the x value to be -1, and not the x value, sorry. The t value to be -1, all the way to 7. We'll leave the t-step where it is because that's a nice number. I'm going to drop this back down to -10. And I'm just going to hit graph and see what it looks like. So again, I need to increase in the -x direction. I should have just left it. Too far, too far. I'm going to go 15. Man, things just aren't easy sometimes. You've got to be kidding me. You're just messing with me now, graph. You're just trying to be mean. There we go. So I can see that this particle changes directions twice. When I hit trace, it starts here, so it travels in the horizontal direction a little bit, and then it goes left for a little bit, and then it goes back to being right. So I just need to figure out where's these turns happening right here. So I'm just going to progress, and as I get closer, I'm going to start paying attention to this x value, and I want to see when is this x value at the greatest number. So these are negative numbers for the x value right now. I want to see maybe it goes positive. It goes positive right here, and then let's see, what was that? This is 0.065 and this is 64, okay? So we've found it at 0.1. That is when this is at the rightmost value. So I know that it's moving right from -1 when we started until positive 0.1. Now it's moving back to the left. And so I'm just going to wait until I get close. And then I will be looking for when does the x value now get the smallest, so the most negative over here. So let's see here, it's 0.6, 0.7, 0.8, and back to 0.7, okay? So right here at a t-value of 4.5, this is going to stop moving in the left direction before it turns around. And then if I just hit trace, I can just confirm that it ends way over there at 7. It does. So moving right from -1 to 0.1, moving left from 0.1 all the way until 4.5, and then moving back to the right from 4.5 to 7. There you go. Ooh, back to the normal whiteboard now. We have 5a. We're trying to eliminate the parameter, which remember means that we're trying to go from 2 equations down to a single equation that has no t-values left. So just one equation that has just x's and y's. So this first one I think is very easy because x equals t. I can just take that and do a direct substitution over here and I'll get y equals 2x because t and x are equal. So this is the rectangular equation or xy equation for this set of parametrics, and I can recognize that as a line. For 5b, we're going to do something really similar. I'm not going to actually get t by itself. I'm going to solve for t squared because both of these have a t squared in it, and I think I'll start with this one. So I'm just going to say t squared equals y plus 2, and now I can take this expression and substitute it in for the x. So I'll get x equals y plus 2, which is what t squared equals, plus 2 because of that part of the equation. And I end up getting x equals y plus 4, and we could just rewrite that super quick. X minus 4, that is the rectangular version of that parametrics, and again, these guys make a line. All right, 5c. What we want to do is try to find an 2 to the t. Wow, that's hard, like that many like t sounding words right there, 2 to the t. Whew. So I'm going to start with this one over here, and I'm going to use that negative exponent to rewrite this. So this is really y equals 1 over 2 to the t. It's really difficult to say. And I'm going to cross multiply things over, kind of do a little switcheroo, and I will get that 2 to the t equals 1 over y, and I can now use this to substitute in over here. So I'll get x equals 1 over y, and I'll just, again, write that the other way around, which is that. So here's the rectangular equation for that set of parametrics. This is a rational function. Remember, whenever x is in the denominator, it's most likely a rational function. For 5d, I will do something similar. I'm going to attempt to find an e to the t. And over here is where I'm going to start with. So I'm going to do the reverse of a power of a power. So remember that if we have a power to a power that we multiply, so this is actually just saying that this is e to the t squared, because power of power says I would multiply and I'd get the same exact thing. So what I can do with that now is come back over here real quick, and I can solve this for e to the t is really x plus 1, and I can now substitute that in over here. So I'll get y equals x plus 1 squared. That is the rectangular equation of that set of parametrics, and because this is squared, we know that this is a parabola or a quadratic. For 5e, I already have an idea of what this is going to be as a rectangular based off of the graphing one that we did for 3d, where x was a cosine and y was a sine. So I have a feeling this is going to be a circle, but not positive. Whenever we have the cosine and the sine and we're trying to eliminate the parameter, what I'm going to do is try to isolate the sine and the cosine and then square it so I can substitute it into sine squared plus cosine squared equals 1. So here I will subtract the 1 and divide by 3. So that's what cosine equals, and I will just square both sides as well. So that's going to give me squared, squared, and this is going to ultimately also become squared, and I'll write that as 9 later on. Same exact thing over here. I'm going to do y minus 2 all over 3 equals sine of t, and then I will square everything. So now that I've squared everything, I can substitute these into this lovely equation right here. So sine is going to give me these things right here. So I will have y minus 2 squared all over 9. Cosine is this stuff, so plus x minus 1 squared over minus 1, you can't tell, minus 1 over 9 equals 1. And we could leave it this way, but when the denominators are both the same, we typically recognize that this is an actual circle, and so we'll rewrite it as an x squared plus a y squared equals an r squared. So this is a circle with a center at 1, 2, and a radius of 3. So that was my initial guess based on the fact that x equaled cosine and y equaled sine. And look at, here's that 3 value, and that's what the radius was. And then we have the 1 and the 2, and that's where our center was. So we're going to spend a little while from now, a couple days, dealing with modeling circular motion. And this is what we're going to be making connections to. The fact that we have a 1 and a 2, and that was our center. We have these numbers right here, and those were our radiuses. And then we're going to see if that sine and cosine does anything, if maybe we switch it. What if we let the y value have a cosine and the x value have a sine? So 5f is annoying because it's just 5e, but with no numbers whatsoever. So it's allowing us to start making a really strong connection between parametric and what the ultimate rectangular form would look like. So I'm just going to do the same exact thing we just did. I'm going to try to isolate the sine and the cosine. So I'm going to subtract h and divide by a, and that will equal cosine. And then I will square everything. So I'll just put parentheses around this one and just call that one a squared. Same exact thing, y minus k over b equals sine t, and then I will square everything. Don't need those parentheses. Ooh, that was a great noise. I'll substitute it into sine squared plus cosine squared equals 1. Okay, so sine squared plus cosine squared equals 1. Here's what sine squared equals. Here's what cosine equals. I'm just going to reverse them because we typically write x first, even though that's really the cosine value. And so we get this lovely equation, which is the general form for an ellipse. Because remember, if we have both squared and there's a plus sign, it's most likely an ellipse. We have the center, hk. This is the radius in the x direction of the ellipse, and this is the radius in the y direction of the ellipse. So we have the center points, and we have a radius in either direction. Kind of neat. Looking forward to that circular motion day in a couple days from now. For 5G, we have trig functions in here, so we're probably going to be using one of the Pythagorean identities. I think the one that we're going to end up using is 1 plus cotan squared t equals cosecant squared t. So I'm going to isolate the cosecant and the cotan and square them. So same as we've been doing, I'm going to subtract the h and divide by a, and then I will end up squaring everything. Same thing here, subtract the k, divide by b, and I'm going to end up squaring everything. Now I can just directly substitute some things in here. One thing that we might do is actually subtract this to the other side. So we'll have cosecant squared minus cotan squared equals 1. And that way when we substitute in, we already have the equals 1 on the other side, which is what we are going to probably want in a little bit. So I'm going to end up with x minus h squared over a squared, because that's what cosecant is, minus y minus k squared over b squared equals 1. And we recognize this minus with 2 squareds as being a hyperbola with a center at hk. We're going, let's see, in the major axis direction. You don't need to remember any of this stuff, but remember that it's going to kind of open like this. When x is first, it opens up and down when y is first. This distance from the center is what a is, and then we can go up b, and it forms like that weird little box that you use to graph it with like all of that fun stuff. Oh my goodness gracious me. Whew. I don't even know if anyone's watching this. I'm just talking to myself now. Super fun. Last one, 5h. We got secant and we got tan, so we're probably going to be using tangent squared plus 1 equals secant squared. So let's just isolate them. Subtract the h, divide by a. We're going to square everything. You getting the pattern yet? This is like the 4th time I'm doing this in a row. So y minus k over b. Square everything, square everything. That equals tan squared. Let's get this to equal 1. So I'm going to, let's see, I'm going to subtract the tangent so that I can leave it as a positive 1. So I'm going to have secant squared minus tan squared equals 1. And I will just substitute some things in here. So I'll get x minus h squared over a squared minus y minus k squared over b squared equals 1. And what do you know? This is the exact same one we just got in 5G. It's a hyperbola because two things squared with a minus. And it's actually facing the same way, which is sideways. So there you go.